Now we're going to look at horizontal shifts. Now the intuition for horizontal shift is going to be carried over from vertical shift with one slight observation which can seem to be counterintuitive in the beginning. So here's the idea. For vertical shift, right, we were changing the output. For horizontal shift, we are changing the input, which means that the transformation has to be in terms of x. So the transformation has to be in terms of x. Now, just like before, what we did here was we added a and subtracted a from y, or from f of x. So now the transformation is going to be going from y equals f of x to y equals f of x plus a, or going from y equals f of x to y equals f of x minus a. So this is where the transformation is going to live now in terms of x. So let's look at the implication of this graphically. What happens? Now the best way to look at it is to use the linear model, right? Because whatever happens in this linear model, it should be the same for any other function. So let's make these functions y equals x, right? So that's my function, that's my f of x. So if I change x to x plus a, right, that's going to be x. Okay, let's use a different color. This is going to be x plus a. And if I subtract, that's going to be x minus a. So let's plot all three of them. Now y equals x we know is a straight line of slope 1 which goes through the origin. Now what about x plus a? To find the intercept here, right, when x is negative a, y is 0, and when x is 0, y is a. So x0, y a, so that's right here, right? So, and the slope is still 1, which means it's parallel. Whereas the red line, that's going to be when x is a, y is 0, and when y is 0, or sorry, x is 0, y is negative a. And that's right here. So that's my red line. All right. Now, if we are talking about horizontal shifts, what is happening here? In going from the blue to the red line, I am moving right. And in going from blue to the cyan line, I am moving left. Which means that the transformation x changing to x plus a corresponds to a left movement, whereas the transformation x to x minus a corresponds to a right movement. Now this is what I meant by it being a little counterintuitive, is because we are adding, and instead of going to the right, we are going to the left. And the reason that happens is because we are adding to the input, which means we are actually transforming the coordinate plane. So things are happening faster, which means now whatever happened at 0 would already have happened at negative a. That's why it moves to the left. Whereas when we are doing x minus a, we are slowing things down so that what initially happened at 0 now is only going to happen at 1. So it's going to be happening later. And so it results in a right movement. Okay, so for example, with our x squared example, if I do y equals x squared and y equals x minus 1 squared and y equals x plus 1 squared, then on the graph, that's my y equals x squared. The x minus 1 squared will be a right movement, so that will be at 1, and parallel, that would be x minus 1 squared, and x plus 1 squared would be a left movement and still yet parallel. So that would be x plus 1 squared. Which means, to summarize then, the transformation f of x to f of x plus a moves it a unit to the left, and the transformation f of x to f of x minus a moves it a unit to the right. Okay, so these are what we call the translation movements, meaning moving left, right, up, and down. Okay, so to summarize, we have 4 of these. F of x going to f of x plus or minus a, or let me do it separate, plus a, and f of x going to f of x minus a. These are changing the outputs. So these are moving up, and this one is moving down. Whereas f of x going to f of x plus a, that's a left motion, and f of x going to f of x minus a, that's a right motion. Okay, and then you can do a similar activity on Desmos. So if you go to desmos.com/calculator, and now you plug in y equals x plus a squared, right? And then you do the slider, and you get the slider for a. Now when you move this left and right, your graph should move left and right. Okay, because for different values of a, this is going to move left or right. Okay, now let's look at an example where we have combined movement. Okay. So combined movement would be, let's say the problem says plot f of x equals square root of x minus 3 plus 4. Now the step 1 is going to be to identify the base function. Identify the base function. Now what does that mean? Here the base function is a square root, and then the square root gets transformed to square root of x minus 3, and then to square root of x minus 3 plus 4. So that's my base function. Now step 2 is identify the transformations one at a time. Identify the individual transformations. Okay, so basically one way to get to that is you start with square root of x, then you change that to square root of x minus 3, and then you change that to square root of x minus 3 plus 4. And for each of these, what is the transformation that you make? The transformation here is you're changing x to x minus 3, and here you're changing f of x to f of x plus 4. So to describe in words, here it's a shift to the right by 3, and this is shift up by 4. And then step 3 is to do the plots. So once you write out step 2, everything becomes simpler because now you know exactly what you have to start with. So you start with the graph for, so it's going to be step 1, step 2, step 3. So you start with the graph for f of x. So that's square root of x. Square root of x looks like that. Okay, and this point is 0, 0. Now with your first transformation, you're going to shift this right by 3. So if you shift this right by 3, the 0, 0 becomes a 3, 0, but the shape doesn't change. So this is now square root of x minus 3. Then you make the second shift, which is you shift this up by 4. If you shift 3, 0 up by 4, it's going to start at 3, 4 and retain the shape. So that would be square root of x minus 3 plus 4. Okay, so that would be the steps that you follow. Now note, there is another way you could have reached the same conclusion, which is you could have gone root x, then you could have added 4 to the output and then transformed the x to x minus 3. That would be the same because that just means you would shift up by 4 first and then you would shift right by 3. So if you think about it, shifting up by 4 and then right by 3 gets you to the same place as shifting right by 3 and then up by 4. So they work out fine no matter what order you do them in. Right? What is important is that the transformation x to x minus 3 is a right shift and the transformation f of x to f of x plus 4 is an up shift. All right, so that brings us to the end of the translation transformations. In the next videos, we are going to look at reflections and some other kinds of transformations. Thank you.